Greetings, everyone. Today we're going to explore solving equations with rational exponents. You'll definitely want to take notes with these examples, and you may or may not need a calculator. Remember that solving equations involves getting x by itself. You're going to use inverse operations. So for example, instead of adding, we would subtract to the other side. Instead of square rooting, we're going to squared and use reciprocal fractions. Make sure you check your solutions to see if they are accurate. Let's take a look at this first example. I'm going to show this example two different ways, and you choose the way that makes more sense to you. So this may require you pausing and choosing which one before you write your notes. To start off with, on each process, I'm going to do the opposite operation of adding 12 to both sides. Next, since I have 3 times x, the inverse operation would be to divide. Now what we're most familiar with is to rewrite that as x index of 5 exponent of 2. The opposite of squaring is to square root. If I square root both sides, I end up with a positive or negative 2 on the right side. So again, that's from square rooting both sides. The opposite of the fifth root is to take it to the fifth power. If I take both sides to the fifth power, I have x equals positive and negative 32. Negative 2 to the fifth stays negative, so we keep that sign. That's what we're most familiar with. Let's look at another option. My second option starts the same way. We're going to add 12 to both sides. We're still going to divide by 3. But now we can multiply both exponents by the reciprocal. So instead of 2/5, it's times 5/2. 2/5 times 5/2 becomes 1. That's why it works out. This would leave me with 4 to the 5/2, which is the same as saying 4, the squared root with the fifth power. Well, the square root of 4 is positive or negative 2, still to the fifth power. Positive or negative 2 to the fifth power leaves me with plus or minus 32. So at this point, choose the side that makes the most sense to you. The reciprocal does seem a little quicker, but on the left side, we're using the same process that we've been using from the beginning. There's no new rules in this case. Make sure that you check both answers, meaning plug the positive 32 in and the negative 32 in. In this case, they both check out, so they are both solutions. Let's take a look at a similar example. Again, I'm going to solve this two ways. No matter what, first of all, I'm going to add that 1 over to the other side, and let's make that an 8. I'm going to rewrite this in what I'm familiar with, and that is the fourth root. So my index is 4 and my exponent's 3. To get rid of cubed, I'm going to cubed root both sides. That simplifies my left side down to the fourth root of x plus 2. And the cubed root of 8 is 2. Next, the inverse operation of fourth root is to take everything to the fourth power. The left side then is left with an x plus 2, and the right side is left with a 16. Inverse operation, let's subtract 2 from both sides, and we get 14. Let's look at it a new way. I'm still going to add that 1 to the other side. But next, I'm going to multiply both exponents by the inverse. So technically that 8 has a 1 exponent, so I'm multiplying it by 4/3. On the left side, that leaves me with x plus 2, because all of this becomes 1. On the right side, I'm left with 8 to the 4/3, which can be rewritten as cube root of 8 to the 4th power. Well, the cube root of 8 is 2 to the 4th power, so that still brings me to my 16. And when I subtract 2, I still arrive at 14. So again, write down the option that makes the most sense to you. And as always, check that 14, plug it back in. And in this case, it works out very nicely. Let's take a look at one more example. Again, this one has a very easy first step. I'm going to subtract that 3 to the other side. Now this time you'll notice it's just to the 1/3. Well, that can very easily be thought of as the cubed root. The opposite of cubed rooting is cubing, which on the left side leaves me with an x plus 2, and on the right side brings me to 64. Subtract 2 from both sides, and we arrive at 62. Again, you have that additional option. If I would rather multiply the exponents by the reciprocal, which would mean times by 3/1, 1 times 3/1. That would take my left side down to x plus 2 and my right side 4 to the 3rd. We still arrive at the same solution. So again, please write down the option that makes the most sense to you. Stick to that method. For the next class to go along with this video, you're going to have a worksheet for solving equations with rational exponents. Let me know if you have any questions and take your time with these problems and make sure to check those answers.